Hello everyone, this is question 7 now on paper 1 from 2022 for Edexcel. And it's a proof by contradiction question. So it says, given that p and q are integers such that p times q is even, use algebra to prove by contradiction that at least one of p or q is even. Now, first things first, we've got to basically come up with our what's sometimes referred to as our contrapositive statement, which is where we assume something that's the opposite of and show that it leads to a contradiction. Now we're given that p and q are integers, so we can't be changing that, and we're given that p times q is even. So basically the things that are given that we're not going to be changing are the fact that p and q are integers and the fact that p times q is even. Okay. It says prove by contradiction that at least one of p or q is even. So therefore the opposite of at least one of p and q being even is that both p and q are odd. Okay, and I think that's maybe a little bit tricky. So there's our bit that we've changed. Okay, so we're basically keeping the fact that p and q are even, and we're keeping the fact that p and q are integers rather, and we're keeping the fact that p times q is even. But what we've changed is, instead of saying at least one of p or q is even, the opposite of that is that both p and q are odd. Okay, right, so given that that's our assumption, let's start off then. So we're going to say that p is 2 times something add 1. So I've said p is 2 times m add 1. And I've said that q is 2 times n for November add 1. So therefore, let's work out what p times q is. So p times q is going to be 2m add 1 times by 2n add 1, which is going to be 4mn plus 2m plus 2n plus 1. Now I can take out a common factor of 2 from that whole expression, giving me 2 times, open bracket, 2mn plus m plus n, close bracket, plus 1. Now, because this is 2 times something add 1, it is odd. Now this contradicts our assumption that given that both p and q are odd, that p times q is even, because what we found is p times q is odd, whereas our initial assumption said we're going to assume that p and q are integers and that p times q is even. So we've got a contradiction. We're assuming that p times q is even, but we found it to be odd. So therefore the opposite must be true, and at least one of p and q are even as required. So that's our proof by contradiction. Right, the second one, it says, given that x and y are integers such that x is less than 0 and x squared is less than 9x squared add y squared. Sorry, x add y squared is less than 9x squared add y squared. Show that y is greater than 4x. Okay, so I'm going to expand my bracket. So x squared add 2xy add y squared is going to be less than 9x squared plus y squared. So we can take y squared off both sides. What else can we do then? Then we can, then basically take x squared off both sides. And that leaves us with 2xy is less than 8x squared. We can divide both sides by x, but because x is negative, we've got to remember to change the direction of the inequality here. And then finally, the last thing is we can divide by 2. So we end up with the fact that y is greater than 4x, which is exactly what we were required to prove. Okay, I hope you found that helpful, and I'll see you in the next video.